The second part of this course focuses on selecting the correct ESA lens diameter, a very important element of the fitting process. Selecting an incorrect diameter will cause the lens to sit on inappropriate areas of the cornea. As mentioned in the first section, an overly large lens diameter can result in an undercorrection. An overly small diameter can result in lateral lens decentration, usually in the nasal direction. Do not pay attention to the bubble in the tear reservoir zone. It is simply air trapped under the lens. A limbal gap, that is, the distance between the lens edge and the limbus, of 0.4 mm around the entire circumference is desirable. This is an ideal example, however, in reality most corneas are elliptical, meaning that the vertical diameter is smaller than the horizontal one. Therefore, the limbal gap may in fact be larger than 0.4 mm along the horizontal meridian, 0.5 mm, 0.6 mm, or even more, and slightly less along the vertical meridian, up to 0.2 mm, and in exceptional cases even as low as 0.1 mm. Here is an example of where reducing the gap along the vertical meridian to 0.1 mm is acceptable. The lens must never infringe upon the limbus. This is not only due to possible undercorrection, but also because prolonged mechanical impact can damage the limbal stem cells, which can compromise long-term corneal health. While scientific evidence regarding the long-term impact of Ortho-K lenses on the limbus is currently absent, avoiding mechanical contact is advised as a preventative measure to preserve the integrity of the corneal growth zone. Developing accuracy in measuring the limbal gap is a skill that comes with experience, and the width of the edge lift can serve as a visual reference. Additionally, the manufacturer's engravings provide a reliable internal ruler, as the symbols are produced to a specific height that can be used to gauge the surrounding gap. The appropriate lens diameter is determined using a diagnostic trial set. This set is comprised of two distinct series of 11 lenses each, or 22 lenses in total, allowing the practitioner to physically verify the limbal gap. You can see here that the trial set contains a full range of diameters, but only two nominal K values out of the 45 that are available. Consequently, the trial lens will rarely match the patient's corneal geometry perfectly. Furthermore, because these lenses are axisymmetric, they may not align well with astigmatic corneas. While these factors can make the initial fit appear inadequate, accurate diameter estimation remains entirely achievable with focused observation. Selecting a lens with excessive sagittal depth, a tight or high fit, is often advantageous when determining the correct diameter. This increased depth stabilizes the lens, minimizing movement and aiding centration. The lens edges are clearly defined, allowing for a more precise assessment of the limbal gap. As a general rule, the lenses with a nominal K of 8 mm are preferred for flatter corneas, where flat K is greater than or equal to 8 mm, whereas the lenses with a nominal K of 7.5 mm are better suited to steeper eyes. On exceptionally steep corneas, where flat K is less than 7.3 mm, a nominal K of 7.5 mm will result in a relatively shallow fit. However, such cases are clinically rare and unlikely to impact standard fitting workflows. For such cases involving extreme corneal steepness, a third series with a nominal K of 7 mm is available upon request. Excessive fluorescein application should be avoided. An oversaturated tear film reduces visual contrast and obscures the precise transition between the transparent peripheral cornea and the limbus. The diameters should be evaluated primarily along the vertical, the shorter, meridian. Because the vertical corneal diameter is typically smaller than the horizontal, this meridian represents the highest risk for limbal impingement. As emphasized previously, maintaining clearance in this zone is important for protecting the limbal stem cells. That is why the primary difficulty in diameter selection is posed by highly elliptical corneas, since the lens is circular. An adequate diameter along the vertical meridian will be insufficient horizontally. This lack of horizontal coverage can lead to lateral decentration, causing halo effects and double vision. An acceptable diameter along the horizontal meridian will be excessive vertically, which will lead to 1. Limbal impingement, and 2. Possible undercorrection that cannot be resolved by increasing the target power. Therefore, for highly elliptical corneas, the fit requires a compromise between possible lateral decentration and possible undercorrection. The general rule is to increase the diameter beyond the desirable limbal gap, providing the lens remains clear of the limbus along the smaller meridian, which is almost always the vertical one. Having said that, the pupil's location must be considered. If the pupil is naturally displaced in the same direction as the lens, lateral decentration may be clinically acceptable. In such cases, the lens and pupil remain aligned. Assessing ESA lens diameter sometimes challenges even experienced practitioners. To bridge the gap between theory and practice, the next module features 20 clinical video case studies, providing real-world examples and expert analysis.